Hello guys, today we are back again. Today we are going to be solving questions of sets, and this time around I'm also going to be solving these questions on LeetCode as well, because uh, only that way the number of problems that I'm solving on LeetCode are going to increase. So for that, so I'm going to be starting from the first problem. I will try to get through each of the problems as quickly as possible. You can also try them out with me if you want to. I will start with the first one. I will mute myself now. Okay, so the first problem was extremely simple. In this, we just had to count the number of distinct elements given a vector of integers. So you can just solve this question simply by just putting all of the elements in a set, and since set only stores distinct elements or unique elements, there are no duplicates. You can just print out the size of the set to find the number of unique elements. An extremely simple question. Let us solve it on LeetCode as well now quickly. Again, in this, here return fields, any value appears at least twice in the written process element is distinct. Because this is a very simple question. If there are duplicates, then we have to print true, otherwise we have to print false. So what you can do is you can create an unordered set S, and let's fill it up with the values of nums, and then you can just compare their size. So if their size is equal, That means there were no duplicate elements. You can just return false in this case. Otherwise, you can return true. That is it. Let us try running it. Okay, very simple question using set. But you don't necessarily need to use set in this case, but since we are practicing sets, it's better to practice them. Now I will move on to the next question. You can also try it out with me if you want to. I will mute myself now. Okay, so the second problem was a very simple question to practice the functions of sets. In this, we were just given a set of strings and we had to find a specified string and or basically check if that specified string is present in the set of strings or not. So what I did for this is very simple. Is first of all I took the input of the whole vector of strings. After that, I creating a string s, which is the specific string that we need to find. Then there is an endline buffer left, so we have to first catch that using a get line. Then you can again use get line to get the specified string in s. Then we can just use the find function of the set. If the find function does not return the end of the set or the end iterator of the set, that means that we have found the element in the set, otherwise we have not found it. Simple as that. Then you can just print true and false accordingly. Now this question was not anything special, just to practice fundamentals of set. I could have skipped it, but it's fine. Now again, the third question I'm going to be skipping for now because it tells me to read a list of words and then print them in alphabetical order without any duplicate. So what you can do in this is you can just create a normal set instead of an unordered set. Just create a normal set. It stores elements in a sorted order, so you can just put all of the elements in that set. It will remove the duplicates and then you can just print all of the elements out of the set in the order. So I'm going to be skipping third question for now. Now let us see the fourth one. Intersection of two arrays. Find the common elements between two unsorted arrays. The result should not contain duplicates. Okay, so I will be trying the fourth question. You can also try it out with me if you want to. I will mute myself now. Okay, so I've solved the fourth problem as well using sets. In this, we were given two arrays and we had to find the intersection of these two arrays. Now, these two arrays were given in unsorted order, and we were told that the result should not contain any duplicates. Now, since the result is already telling us to not contain any duplicates, we know that the problem can easily be solved using stacks. Well, sorry, using sets. So, what I did for this is, first of all, I took the input of both the vectors, then I created two pair of sets. Now, why I'm creating a pair of sets instead of unordered sets, I will tell you in a moment. So I created this order of sets. Now sets store elements in sorted order. So the first one is going to be storing the elements of the first vector in sorted order and unique elements as well. Second one as well for the second vector. And I created a set called result. Now, since sets in C++ do not directly have inbuilt set operations, so you have to use these operations from the algorithm header. So you have to include this algorithm, hashtag include algorithm. From that, you can use set underscore intersection or other operations as well, such as difference, union, etc. So in this, first you pass the beginning and ending iterator of the first set, and then the beginning and ending iterator of the second set. And then you use this inserter, and inside this inserter you pass the result set and the beginning of that result set. That way you can store the result in this result set using this inserter from these two sets. Now why we are taking sorted sets is because this set underscore intersection operation only function on sorted sets. If we are using unordered sets, then we will have to create the logic accordingly. These inbuilt functions would not work. So to use the inbuilt functions, you have to use ordered sets. Initially, I was using unordered sets, so it was not working. Then I switched to sets, and it worked completely fine. So keep that in mind when you're using inbuilt set operations, for example, intersection or other operations like that. You have to use them on sorted order of sets. So this is the way that I solved this problem. First, the iterators of both the vectors and then inserter of the result, and then you can just print the result out like this. I've checked it, the solution works completely fine. Let us try solving it on LeetCode as well. I think it exists on LeetCode. Yeah, it is right here on LeetCode. So since both the vectors are already given to us, we can just directly create the set for these. S1 underscore beginning. Then now you can just create a result. Since the result is going to be a vector, you can just create a vector, I guess. Let us see if this works or not. Intersection. Let's see if this works or not. Okay, the solution seems to work completely fine. Yeah, so the solution works completely fine, completely correct. You can also try solving it if you want to. Now I will move on to the next problem, which is the union of two arrays. You can also try solving this with me if you want to. I will mute myself now. Okay, so the fifth problem is extremely simple. Just like the previous question, we were taking intersection in the previous question. In this one, we had to take union. So for union, you don't even have to use the inbuilt function unless you are already using two sets. If you have a vector and you are creating a set, then you can just put the elements of the first vector in the set first, then the elements of the second vector, because it already removes the duplicates. And since we are taking the union of both the vectors, this should work completely fine. So yeah, this works completely fine. So we just had to find all unique elements present in either of the two unsorted arrays. So yeah, basically the union of two arrays, very simple. And since unique elements is mentioned already, you can easily use a set. Otherwise, you could have used a multi-set as well if it was mentioned that you could have had duplicates. But anyways, it's fine. Now we can just move on to the next problem. This union of two arrays is not even available on LeetCode, so you can just solve them for yourself. Now we can move on to the medium level problem. You can also try it out with me if you want to. I will mute myself now. Let me write. Okay. Okay, so I have solved the first problem in the medium problem set. The first problem was to find the kth smallest elements or kth smallest distinct element. As soon as you hear the word distinct or unique, you can think of sets or maybe even maps if required, but usually sets. So we were given an unsorted array of integers and we had to find the smallest kth smallest distinct element. Now as soon as you hear the word distinct, you can just figure out that the solution might require sets. So since we are supposed to find the kth smallest distinct elements, that means that we need it in a sorted order. So for a sorted order, we can use a normal set and you can just put all of the elements inside of it. Then obviously if the size of the set is smaller than the k that we passed to it or the kth smallest element required, then obviously there can never be a kth smallest element possible. So in that case, I would just print no kth smallest element. Otherwise, I would take first the beginning iterator of the set and then I would advance it by k-1 positions using the advance operator, and then I will print the output. This way we can solve this problem. Now the problem given in lead code is not the same as this. In that problem we have to find the kth largest element in the array. Now this question, kth largest element in the array, is not asking for distinct elements. So you can easily solve this question using something like a priority queue, because in the priority queue you can have elements in a sorted order without actually sorting the array. So you can solve it using a priority queue if needed. I have solved it using a set because I'm practicing sets. This is my solution. Very small, very simple, but if you want to solve it the actual way it is probably supposed to be solved, you should use something like priority queue. So the solution would look something like this. Basically, you can just add elements in the priority queue. You can just use a normal priority queue, and since you want the kth largest element, just pop that many elements or k-1 elements from the top of the priority queue, and then the topmost element of the priority queue is going to be the element that we need. Or we will be removing from the front. It's a queue, I forgot priority queue, but I am sure you understand what I'm trying to say. The priority queue always has a the topmost element. So yeah, from the priority queue, we'll start removing from the top and accordingly solve it. Then try solving it if you want to using a priority queue. For now, I will be moving on to the next question. You can also try it out with me if you want to. Next question, again, I've read it. It doesn't really feel like a set question. It feels like more of a map question, but I will try solving it using sets. I will mute myself now. You can also try solving it along with me if you want to. Okay, guys, so I have solved the medium level second problem as well, which was sliding window distinct count. Now this is a problem that can easily be solved using maps, but since we are supposed to be practicing sets, I solved this problem using sets. I will explain how. So first let me explain what we had to do in this problem. We were given an array and a window size k. So we were supposed to find the count of distinct elements in each window of size k. So for example, we'll show you. Yeah, for example, we have this test case. And in this, the window size is 4. So each window of size 4, which is going to be first this, then this, then this, and then finally this. In each of these windows, we have to tell what is the count of distinct elements. So this is clearly a sliding window problem since we are given a window of size k. So that is the way I solved it. So let me explain it to you. First of all, I took input for the vector and where the window size k. Then I created a set of pair of integer comma integer, which will be behaving as a map for me as an element comma frequency pair. And for this, I had to create a custom comparator because in general, this set is going to be comparing with the whole value that is provided to it, which is going to be the whole pair. But we just want to compare using the first element, or basically using the key instead of the value. Since we want it to behave as a map. So what I did for this is I created a custom comparator, and the return type of this operator is bool. In this, I'm passing two pairs, and we are just going to be checking for the first value of these pairs. So if the first, or if basically the key of the first pair is less than the key of the second pair or not, so it will put them accordingly that way. So this will be ordering these elements, by the way, and we don't need that order, so we can also use an unordered set, and for that we can use hashes. I will explain that as well in a bit. First, let me explain this solution completely. So I've created a set here with key value pair, and I created a custom comparator for it, comparing the first of the pair of both, or basically the keys of both the pairs. And then I created left and right variables, which are going to be the 2 pointers of the window that we are sliding. And then we get into the main loop, which is the while loop. We will run it until the right is less than the size of the vector itself, or basically until we reach the last window, you can kind of say. So first we created this element or this pair. So first of all, we are going to be checking if we have a window of size k or not, because only then we can start sliding. So first we are going to be putting elements in the set, but not sliding the window until we have a window of size k. So this is the condition for that, until the window size is less than k minus 1, or right is less than k minus 1. So in this, first we are going to be finding the vector that we are supposed to find using the custom comparator that we created. So as the value you can pass in anything, it won't be comparing with that. It will only be comparing with the key according to the custom comparator that we created. Then if it is found, then in that case we are going to be putting the element that we created initially equal to this equal to this element by dereferencing the iterator. And we are going to be raising this iterator, and we are going to be updating the second, or basically the value of this element by 1, increasing the frequency of the element by 1. Otherwise, if it is not found, then we can just create the element like this, the key, which is the element itself, and the value being 1, because we have only found it once by now, since it is not already in the vector, or not already in the set, which is the window itself. And then we are finally going to be inserting this element in the set. So in maps, what we do, we can just directly update the value using the key, but in sets we cannot do that. That is not allowed. So first we have to erase the element, then we have to add the new element with the updated key. So that's an extra step. After that, we can just update the right pointer and continue. And if we have reached the point where we have a window of size k, then in that case again we are just first going to try and find that element. If it is found, then we are going to be erasing it and updating the second of the element or the value of the element by 1, frequency by 1. Otherwise we will set it to 1 and then insert in the set. Then we are going to be pushing the size of the set in the result, because the size of the set is going to be the number of distinct elements, since it is behaving as a map. So each key is going to be distinct, and then what we can do is we can remove the left element, because when we will be moving the window forward, we will be removing one element from the left. So you can just first of all find the iterator for the leftmost element. In this case, you don't have to check whether it is present or not, because it is always going to be present since it is already present in the window. Then you can update the element by dereferencing this iterator and erase the iterator, and decrease the frequency count of this element by 1. Now if the frequency count becomes equals to 0, then we don't want to do anything. We just want to keep it removed from the set. And otherwise, if the frequency count is greater than 0, which means it is still present in the window, then we are just going to be adding this updated key value pair in the set, and then we are going to be updating the left and right pointer and then continuing with the loop. So this is the simplest solution for this problem using sets that I could think of. Otherwise the problem would be far more simpler if we want to solve it using maps. Anyways, now I was using a set before because I had created a custom comparator which was comparing two values, but this time I'm going to be creating a custom hash, and let me call it a custom hash instead. Custom hash of unordered set. Since unordered set does not order elements, we just need to pass a hashing for it. So you can just pass one pair, and then you can just return the hash of your node first. Just a second. Let me return the return type as well. It is not going to be boolean. We are returning a hash function. Now, yeah, you also need to put this here. Yeah, this should work. You can make it more complex if you want to. The hash function, I'm keeping it simple by just one value. You can do it that way if you want to. Now we can test the previous test cases again to see if it works or not. Let's see quickly. Hopefully we won't get any error. We did not. Yes, good. Now let us see. Window size is 4. Okay, so it did not do anything right now. Let me just check quickly why. It's 3, 1, 2, 1, 3, 4, 3. Yes, sir. Okay. Okay, I don't know why it did not work just on this way. Okay, so apparently when using an unordered set, we need two things, which is to use a custom hash and a custom equality as well. So the custom hash is going to be comparing using this key. But the problem with unordered set is it is going to be considering the whole pair by itself. So you also need to create a custom equality like so. Custom and then we can just return so this is a bit confusing to me as well. Now since let us put the custom equal in it as well. After the hash we get to use custom equal. So why this works is because it is using both custom hash and custom equal. So the key value pairs are treated as equal if their first is the same. So that is what it is going to be doing. So if the first is the same, then these key value pair are treated as equal, and then the hashing is done accordingly. So it's a bit confusing to me as well. This is the kind of thing that I think we have to practice more to learn. This is very specific to sets as well. I don't think anyone... Yeah, so the code works completely fine. We can test it with more test cases, obviously. Let us see which one. Well, the first one worked, so all of them are going to work, I think. So we don't really need to test it. So remember that when you are using a normal set and you want to create a key value pair using a normal set, then you can use a custom comparator directly using both two pairs, and it should work completely fine. But if you are using an unordered set, then you need two things. First of all, you need a custom hashing with just one pair, and then you also need a custom equality, which is going to be using two pairs, and you are going to be checking if the first, or basically the keys of both the pair, are equal or not. So remember that is something new that we learned today. Now I am also going to be solving the problem that is available on LeetCode, which is supposed to be similar to this problem. So I will mute myself now. You can also try solving it along with me if you want to. I will be using sets over here as well. So I will mute myself. You can also try solving it with me. So I've solved this problem. I will be honest, I was not able to formulate a solution by myself to this. So I had to look up a solution online, and NeetCode's solution to this problem was the best in my opinion. So he used a sliding window in this. It was basically kind of like a dynamic sliding window, you can say. Usually sliding window. So I was trying to solve this recursively, but that would have been an O of n square solution, and since the constraints are too large, I don't think it would have worked. So we needed an O of n solution in this, and for that we needed to use a sliding window. Now, I was not able to formulate a solution myself using sliding window in this question, so I looked up NeetCode's solution. So if you want, you can go and check his solution out. I will explain it myself as well, but for better explanation, you can go to him. So let me explain it to you first. In this question, what I'm doing first is I've defined a frequency map for the elements in the vector, and this is a 3-pointer sliding window problem instead of a 2-pointer. That is the way NeetCode solved it. And the solution was quite intuitive actually. So you should be able to understand it quite well. It was a very good solution. So we have 3 pointers here. One is the left far pointer, one is left near pointer, and one is the rightmost pointer. So I will explain it to you in a second how all of these pointers work. And then we have a count variable, which is the result for us. So I run a while loop until right is less than the size of the vector itself. Then first of all, I update the frequency of the rightmost element in the map. Then the use of the left near element is so that we can keep a track of all the subarrays in between, which would have not been possible by using just 2 pointers. So I will explain it to you how. So first, let me explain this condition. So what we are doing is whenever the frequency of element on the left, or left underscore near, you can say, whenever the frequency of that element becomes greater than 1, so it means there are like too many elements in the window, you can say, which is not technically needed. So you can start discarding off those elements, because we only need distinct elements, and for that we can just use the frequency map size. We don't need to keep duplicates inside of it. So from the left we can start discarding out the duplicates. So that is what we are using left near for. So you can discard out the duplicates until the frequency is greater than 1. So that means there are duplicates available. Until then you can start removing it and sliding the left near pointer 1 position ahead. And the use of left far is that is to be able to calculate all of the subarrays in between. So if we have the left near pointer, and now according to the logic, we know that all the elements in the left near pointer is the frequency of those elements is going to be greater than equal to k, and left far pointer will also have elements with frequency equal to k, exactly, distinct elements, by the way. So the number of distinct elements is going to be equal to k. So you can take all of the elements in between, and all of those would count as subarrays. So that is the reason we are using left far pointer. So we can update the count, basically the number of subarrays currently which have k number of distinct elements. You can just update it by left near minus left far plus 1, which will account for all the arrays in between from left near till the left far. Basically, there will be a sliding window with distinct elements or subarray from left far till right in the sliding window, and one with left far plus 1 till right, left far plus 2 till right, until left near till right. So in that sense, you can just do left near minus left far plus 1. And to update left far, what you can do is whenever the number of distinct elements in the window becomes greater than k, then doesn't matter what you do with the elements in the left, you won't be able to get a value which is you won't be able to get the distinct number of elements in the window which are equal to k. It will stay greater than k, so we will have to start decreasing from left, and none of the subarrays on the left will account for it either. So that is when we are going to be updating left far. So first of all, we are going to be updating left near until the number of elements in the current window becomes equal to k. Number of distinct elements in the current window becomes equal to k, and we will update left far accordingly. And when it has ended, we will put left far equals to left near, because left far is not needed on the far left anymore. Its position can be updated because there won't be any sub arrays till that position from the current right one that will have a count of distinct elements which is equal to k. So I know the solution might not be the most clearest. I mean, my explanation might not be the most clearest. You can go and check out NeetCode.io's solution on this. His explanation was very intuitive. So yeah, I have solved it. I will solve it using a set as well instead of a map because I'm practicing sets. So I will just update this code to be able to use sets. And after that, I will solve it once in Python as well, because now I will be practicing in two languages. On VS Code, I will be solving problems only in C++, but on LeetCode, I will be solving them in both C++ and Python, because I was giving an online assessment for a company, and the only languages that were available were Java, JavaScript, and Python. So C++ was not available, neither was C available. So I was not able to solve the problems because I had not practiced these languages in a long time. I might have been able to, but if I had revised them. So for now, I will be solving them in two languages so that I don't have to sit there completely blindly, in a sense, if this kind of situation occurs again. And if in the future both languages, C++ and Python, are not available, then in that case I will just start practicing with three languages. For now, it is just going to be these two. So whenever I will be solving with Python, you can just skip that if you want to. That doesn't matter. But anyways, I will mute myself now. You can also try solving it using a set if you want to. And if my explanation was not clear, you can check out NeetCode's solution to this problem. And yeah, I will mute myself now. Hello.
Very bad.
So I have solved this problem using a set as well. I was using an unordered set, so I had to create both a custom hashing and a custom equality as well. So then the operations have been done accordingly as I've been doing before, using a set as a map. It's a weird thing. I don't think I'm learning much using a set as a map specifically, but okay, anyways. Everything can be a learning experience. Now, I'm going to be solving this problem using Python. As I said, I was going to be practicing Python as well. So I will mute myself now. You can also try solving this in Python if you want to. So I have solved this problem in Python as well. I'll be honest, this code is basically copied from neat code, basically. But this is it. Since I was not able to formulate a solution by myself in this anyway, so this works. This is very good. Now I will move on to the next questions. I'll move on to the next questions now. You can also try solving them along with me if you want to. I will mute myself now. Okay, guys, so I've solved the fifth problem as well. In this, we were supposed to find the longest consecutive subsequence. So basically, we were supposed to find a subsequence of consecutive integers. Basically, the longest subsequence of consecutive integers, and they don't exactly have to be in like sorted order. They could have been in any order. And I will be honest, I've solved this problem before. That is why I was able to solve it right now as well. I will explain the solution to you quickly. So basically, what we know for any subsequence is that if it is a subsequence of consecutive elements, so basically we have a set of consecutive elements, then the leftmost element will not have a left neighbor, right? So there won't be any element to the left of it. So that is the basic principle that we are going to be using for this. What I did is, first of all, I inputted all of the elements from the vector into a set. Then I iterated the set, and for each element I just checked if it has a left neighbor or not. If it does not have a left neighbor, that means we have found the start of a sequence. So from the start of a sequence, what you can do is you can continuously keep checking if the next element is present in the set or not, using while loop, and update the value and the length of that sequence, and then you can just update the length of the longest sequence uh, accordingly. So that is the way we solve this problem. I have already solved it on lead code once before. I will solve it again. I will mute myself while I am solving it on lead code. You can also try solving this along with me if you want to, if you understand the solution. If you don't, you can check out lead code's video on this. That is probably the one I watched as well when I was not able to think up of a solution for this in the past. So you can check out his solution. I will mute myself right now and solve this problem. Yeah, so I just solved it and it was extracted on lead code as well. I will solve it in Python as well right now, since I'm also practicing another language. If you want, you can skip this part. In this problem, what you have to remember is that for a consecutive sequence or a consecutive set of integers or anything, there is going to be a starting element, and that start won't be having any left neighbor. That is the basic principle. So you just need to find that start of the sequence, and from that start you can just find other elements as well. And since we are using a set, we will be finding the element in O1 since we are using an unordered set. So the overall algorithm is going to be running in O of n time. So I will solve it in Python as well now. I will mute myself. Okay, so this worked in Python as well. We'll move on to the next problem now. You can also try it out with me if you want to. I will mute myself now. Okay guys, so I have solved this problem as well. In this we had to find the k most frequent elements. I think I've already solved this problem when I was doing the map problem set. So this is quite similar. I used the same application. What I did is I first created a map of uh, element as the key and frequency as the value. So a frequency map of the elements. So like the map type will be element comma frequency, and then I reversed that map, created another map which was frequency comma element, and I ordered it in reverse order. So that is the way I solved it. A very simple problem. This was, I will explain the code. Since I am using sets, I created set in this case. First I created an unordered set to uh, like put in the element comma frequency, and using an unordered set, since every application is going to be O1, this part of the code is going to be O of n, which is basically the number of elements you can see. So I created a custom hash for this as we had created before, and custom equality which is required for an unordered set. And then I created a normal set for the frequency comma element count because I want element in order, in sorted order, based on frequency, but in descending order. So for descending order, I am passing this greater functor. So this functor is going to be ordering it in descending order. And since the data type is pair, we have to pass a pair in this functor as well. Functor doesn't require round brackets, so remember that. And then I just put these values in. Then we just print the first k elements from this set 2, or you can say map 2. That is the way I solved it. Let me just quickly solve it in lead code as well to see if the solution actually works or not. I'll mute myself right now until I solve this problem. Okay, so my solution to this problem worked completely fine. I will try coding it in Python now. But I don't think I'm going to be using a set in Python. I will just directly use a map most probably. But let me see now. Let me try to code this in Python. I will mute myself now. You can skip this part if you want to.
Yeah, well,
Okay, so I solved this problem in Python as well. In Python, I was not able to use a second map because Python, I think, does not allow a sorted map, you can say, so, or sorted set. So, in for sorted purpose, I used a list instead. And so what I did is, possible to extend key value pairs in maps in Python. You can't do dot first and dot second. You have to take two values, for example, key comma value in map dot items. So dot items return key value pairs, and from there you can just append it to the list. In this case, I'm calling it map2, but it is a list. So then we can sort the list in reverse order, and then you can just append the elements in result and print the result out. So yeah, this was the problem. We have solved it. Now we can move on to the next one. You can also try it out with me if you want to. I will mute myself now. Okay, so I have solved this problem as well. Find pairs with a given sum. Now this is an easy problem. Basically the first problem of cheat code. So yeah, this is a very simple problem. You don't exactly need anything for this problem. It just says array and hash table. Now this is really simple. You can just basically, I have used just set in this case because I'm practicing set. You can use a map otherwise. So just use a map and store the current value of the vector, comma, its index. And for each element, just check if target minus that element exists inside of it or not. If it exists, in that case, you can just append the previous index, basically the target minus vector of I index and the current index I, and then break the loop. Otherwise, you can put these two inside the map itself. So that's the way you can solve it. Very simple. Now I will quickly finish this up on in C++ in lead code as well. I will solve it for both map and sets because why not? I've probably submitted this question before as anyone else. Yep. So I don't exactly need to submit it again, but why not? Okay, I might have done it using maps earlier, right? Let me just check quickly. Accepted. Okay, there's a solution. Yeah, so previously I had done it using a map, so this time I will just solve the one using sets, and then I will be solving it using Python as well. I will quickly solve and submit both of these. I will mute myself till then. You can skip this part if you want to. So yeah, I will mute myself now. So this solution works completely fine in C++, but I have come to a bit of a realization just now, and that is that if a problem can be solved using a map and I'm solving it using a set, or lead code as well, then it is a waste of my time because this set code is it is completely unnecessary. So from now on, only when I'm practicing myself on VS Code, I'll be solving it using like this set or stuff. Otherwise, on lead code, I will only be solving the question using maps because I don't want to waste my time unless it's a problem explicitly for set, and unless it is that I won't be solving it using the set. So now I will quickly solve it in Python as well. I will mute myself now. You can skip this part if you want to. Okay, so we have completed this very simple. Now we can just move on to the next set of problems, which is the hard set of problem. This should be fun to solve. Finally, after this, we will be able to move on to like trees and greedy algo and stuff like that. So that will be way more fun than this. So for now, I will just mute myself. You can try solving this problem along with me if you want to. I will mute myself now. Okay, guys, so we have solved this problem as well. In this, we had to find all of the distinct palindromic substrings of a string. So what I did for this problem is, since we were supposed to find unique palindromic substrings, obviously we can use a set to store these substrings inside of it. So what I did for this is, if you have never solved a palindrome related problem before, a common method to solve it is to expand from the center. Now there can be two cases to expand from the centers, even case and odd case. So I will explain it to you for both of those. So first of all, I created an unordered set st, and then I ran a for loop from the first character of the string till the last character, because we can get palindromic substrings starting from each of the characters, right? So possibilities from each of the characters. So, and then what we do is we do the expand from the center method. So first we do it for the odd case, for which the left and the right pointer are both going to be the same initially, which is I, or just one element in the middle. And then we will run a while loop. We will run the while loop till like left is greater than equal to 0, because left will be moving to the left, and till right is less than the size of the string, with since the right pointer is moving towards the right. And we will run it while the characters at the left position and the right position are equal. Now if these are equal, then what we can do is we can take that substring and we can insert it in the set, and then we can update left and right pointers accordingly. Now the code for the even case is exactly same. The only difference is that now left and right is not initialized to the same value I, because this is the even case, not the odd case. So there won't be a center element in this. There won't be a middle element. There will be two middle elements. So for that we will take left as I and right as I plus 1. And then you can just do the same logic as we have done before, and then you can print out this set. Now the problem on lead code is a bit different. It is not exactly same as this. In this we don't have to give like the number of distinct palindromic substring. We just have to give all of the palindromic substrings that are possible from this. So for example, we have this A case. This A is possible, then this A in the middle is possible, then this A is possible, these two A are possible, these two A are possible, and then the whole string itself is also palindrome. So it is possible to solve it like this. Now I will also solve it on lead code right now. You can also try solving it along with me if you want to. Then I will solve it in Python. You can skip that part if you want to. I will mute myself now. Okay, so so my code with C++ was accepted correctly. Now I will solve it in Python as well. You can try skipping this part if you want to. I will mute myself now. Okay, so my solution works completely fine. It was accepted in Python as well correctly. So now I will just directly move on to the next question. You can also try it out with me if you want to. I will mute myself now. Okay guys, so seems like I have solved this problem as well. Before I explain the solution, I would just first like to clarify that my solution was not working until now on the specific test case, which was 117 and 8. And I think this was happening because floating point instability. So before I was checking the perfect square like this, and this was the issue, I guess, because of the floating point precision and stuff. So to avoid this, we should just create an integer s of sqrt, and instead of taking the power, we can just take the square like this and then compare. So this works well, and the solution also works. So let me first explain the solution, I guess. So what I'm doing in this is a recursion plus backtracking problem. I have taken the input vector. I'm creating a vector called perm, which is going to be containing the particular permutation. So this permutation will be filled up as we go on, and we have a visited vector. This just keeps a track of which elements have been used so that we do not reuse them. And then we have the set st to just check if a particular permutation has already been checked or not. So we need st because there can be duplicate elements. For example, in this case, we have 2 comma 2 comma 2, so different permutations will be same. So that's why we need the set st. Anyway, so let me explain the solution. First of all, the base cases. If the size of the permutation vectors become equal to the normal vector, that means that we have inputted all of the elements in a different variation inside the perm vector. So we have gotten one of the permutations. So now we are just going to check if the permutation that we have got is already present in the set or not, because if it is already present, then we won't count it. And if it is not present, then we can insert it in the set and we can return 1. So one permutation has been counted of a squareful array. And otherwise, if it is already present in the set, then we can just directly return 0. Then we come to the main loop. First of all, we have this function to check the perfect square, which is a comma b. We just input two values, a comma b, and first we take square root of some of these, and then we check if the square of this square root is equal to the sum of these two elements or not. And I've created a custom hashing as well for the unordered set. So in this hashing, I'm doing nothing. I'm just taking a hash variable and I'm doing a XOR with the previous hash plus whatever is the hash of the current element in the vector. So this is the custom hashing. Now, after the custom hash, we come to the main solution again. Now we are going to be iterating the whole vector, and in the vector we will first of all check if the current element has been visited or not. If it has already been visited, then we can continue, because then we can't put it in the current permutation because it is already present in the current permutation. Then otherwise, if the perm vector is not empty, that means there is at least one element inside of it, so we can check it as the current as the adjacent element with the current element that we have in the vector. So then we can just check if it is a perfect square or not with the current element. And if it is not a perfect square, then we can just continue. We don't need that permutation. Otherwise, we move on. First of all, we put visited of I equals true. That means we have visited this element. Then we just push this element in the perm vector, and then we do a count plus solution vector perm and visited. So this is the recursive call. So we will move on to the next recursive call, and then when we backtrack, then we are going to be putting the current element visited as false, because now we are popping it out of the current position like this. So that is the backtracking part, and then we can just return the count variable. So this is the solution. For the most of it, this works, but The only problem that I had with my solution is that I was not checking perfect square correctly because of the floating point precision inside of it. So to be careful of that, you can do it like this. Just create a separate variable for the square of these two elements, the sum of square root of these two elements, and then take a square of that variable and then check it with the sum of these two elements. So that's the way you can do it. Now, this might not be the most efficient way of doing it, and I think I don't need to create the visited vector either in this case, because we might be able to solve it without it. So now I will solve it in lead code. I will try solving it without the visited vector first to see if the solution works or not. You can also try it out with me if you want to. I will mute myself now. By the way, my hashing is not the most efficient either. This can cause collisions, but in our case, we don't need to worry about this collision specifically. So we are kind of good to go, you can kind of say. But yeah, since it can cause collisions, what you can do is you can modify it. For example, you can just multiply it with a random value, let's say 39, and this should work as well. Let me try running it first to see if it actually works or not. In 78, yeah, so this works fine. So the more complex you make your hash, the less chances of there being collisions. So now I will just move on to solving it on lead code again. I will mute myself. Well, although my code is mostly correct, I'm getting TL in it, so I think I have to do something with the duplicate elements. So I will have to figure something out for the duplicate elements. I will optimize my code further now, if possible. I will mute myself now. You can also try solving yourself or making it better. I will mute myself now. Okay, so with the help of online sources, basically ChatGPT, I understood how to avoid the duplicates. So what we are going to do first is we are going to sort our array nums. So let us sort, sorry, in this case it is vector, right? Vector. Now why we are sorting is because when we sort, the duplicate elements are going to come next to each other, right? And the basic principle in this is that you don't use the next duplicate element before you have used its previous one. Unless you have used its previous one, you are not going to be using the next one. So that is a way of avoiding duplicate permutations. So basically, if you have ever done permutations and combinations, as you might know, when you're taking all permutations of a particular set of characters, you divide it by the factorial of the duplicates, right? By factorial of the count of the duplicates. Now, you do that because you want to get rid of like those extra duplicate permutations that you usually do. So the way we do that in code is to just avoid those duplicate permutations by first sorting the array so that the duplicates are next to each other, and then each time for each permutation, before using a duplicate, we need to use its first duplicate or the duplicate right before it. Otherwise, we don't use that one. That way we can avoid using duplicates. So now let me write the condition for that quickly. And vector of I minus 1 will equal to vector of I. So if I is greater than 0, then obviously we have more than one element. Then we can start checking if the previous one was duplicate or not. Then this condition just checks if it was a duplicate or not. And then we are going to check if the previous one was already used or not. So if the previous one has not been visited yet, it has not been used yet, then we will continue because we don't want to use the current one until we have used the previous one. That way we can avoid duplicate permutations. So let us see, even for this example, if it works right now or not. Let us see the first basic examples first so that we know it still works. Yeah, this still works. So let us see something like 2, 2, 2. Yeah, so we are able to see only one permutation in this, right? So let me quickly do this. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. So this solution works. Now all we need to do in this is first sort the array itself. Sort So always remember this method of solving to see if there has been a duplicate or not. Now, since we want to check if the previous one was duplicate or not, in this case we can just directly, we cannot directly check it. So I will have to use the visited vector for this. So I will have to create the visited vector no matter what. So yeah, let me quickly do that. This is going to be a Boolean vector. And dot size comma false, as nothing has been visited yet. Let me put visited over here. Visited. Let me edit the code. After perm, we will add vector bool
Third.
visited. And then inside the code, we are just going to be checking for each one.
It looks good.
Instead of this condition, we'll just use if visited. So if it has been visited, then we can just continue. Similarly, this is correct. And then let us edit this first. We just need to put visited of I equals to true in this. And let me pass visited over here as well. and instead of this, you can just put visitor of I equals to false. Let me also update this quickly. Vector phi. So let us see if this solution works or not first of all. Before we do, okay, if visited, okay, where is visit? Yeah, so this should be visited. Okay, so this solution works now. To avoid duplicates, we have sorted the array nums, and then we will just use the condition that if the previous duplicate has not been used, then we just skip. Okay, so hopefully this would work completely fine. Let us see though.
Thanks.
Now this was a very difficult question. Yeah, this was a very good problem. I really liked it. Very difficult it was. So yeah, good question. Really good question. Now I will try solving it in Python as well. You can skip this part if you want to. But since I'm practicing in Python as well, I will be solving it in Python now. I will mute myself now. I hope you also enjoyed this question as much as I did. I will mute myself and solve it in Python. You can also try solving it in another language if you want to. Otherwise, you can just skip this part. Okay, so my solution for, in Python worked also, although it took some attempts to correct it. So basically the things that I needed to get right in Python was that, first of all, when I'm trying to create a set, I have to use the function to create the set, and then to add elements is dot add, and you can't directly hash a list in this. So what we can do is we can first create a tuple, or we can just change the list to a tuple and then add it to the set. Other than that, another thing to check was that since the data type is not directly defined in this, and it just takes whatever data type is given to it, it was taking the square root of a plus b, which could have been a float value as well. So for this, we needed to first convert it to an integer and then do it. So this solution works well. Really good question in my opinion, really great question. Now we can just move on to the next one. You can also try solving it along with me if you want to. I will mute myself now.
It don't.
Okay, so I have completed this question as well. In this, we were given a set of xy plane points, and we just had to find the minimum area of the rectangle that can be formed using these points. So I will explain it to you using paint. Okay, so I hope my screen is visible. So in a set of xy points, we can get any sort of x and y points. So what we can do is we can start by plotting them on a graph. For example, we have a point. We have this point. This is just coordinates x and y. Now to create a rectangle, for example, we will need any point on, first of all, the y-axis. So you can call it anything, or you can also start with the horizontal axis. It doesn't matter, but it can be anything with the same x value but a different y value, right? So the y value is going to be different, or it is going to be varying only on the y-axis, right? And similarly, along the horizontal axis, we can find another point which will be shifting its value only in x-axis. So this point is going to be x plus x dash and y, right? And similarly, the last point, which is going to be the diagonal point for this point, is going to be x plus x dash and y plus y dash. So what we need for this problem is we need these 4 points to be able to create a rectangle, and then we need to calculate the area of this rectangle and see if it has a minimum area or not. So how do we find these 4 points is the main question. So what we can do is we can just try finding a diagonal point first, and any point which is diagonal to this will have a different x value and a different y value, right? As we can see, both of these points, let us call this diagonal point and just call this normal point P. So x and y values of point P and D are different, right? So whenever we hit a different set of values of both x and y, we know it can be a possible diagonal of a rectangle. So from here, what we can do is we can try swapping their values. For example, we have x and y, and we have x plus x dash and y plus y dash, right? So as we can see, for example, this point on the horizontal line, it has the x value of the diagonal point and the y value of this point P, right? Let me write this again. Yeah, so it has the x value of this diagonal point and the y value of this point P. So we can take the x value of this and we can take the y value of this, right? And similarly, for this point on the y-axis, it has the x value of point P and the y value of the diagonal point. So let me draw this as well. We have this point x comma y plus second s y dash, right?
Yeah.
So we are getting the x value from this, and we are getting the y value from the diagonal point D. Okay. So this way, what we know is that if we have found this point P and a diagonal point, then we can just search for this point and we can search for this point, right? Using the x value of one of the points and the y value of the other point, right? So we just need to find these 2 points now. And these 2 points can easily be found using the current point that we have and the point to its diagonal. So if we have found these 2 points as well, then it means we have found all the 4 points needed to make a rectangle. Then what we need to do is we need to just take the area of this rectangle. Now this is simple. We have the point P and we have the diagonal point. Now you can take the absolute difference of the y coordinates and you can take the absolute difference of, just a second. you can take the absolute difference of y coordinates, and you can take the absolute difference of the x coordinates as well, right? And then you can just take a product of these two, and that will give you the area of this rectangle. So that is the explanation of the problem itself. Now I will show you the code. So in this code, first of all, I'm taking the input, obviously. Then I've created this unordered set, and for this I have to create a custom hash, obviously. So I've created the custom hash since we are taking a set of vectors in this case, and the vectors have only two values, which is the x and y coordinates. So you can return a hash with these two values. As you can see, I've created a hash like this. You can do it any way you want. And then I take the min area variable, assign it the most maximum value possible. Then I iterate set xy, and I iterate diagonal point from set xy as well. And then if a point, basically if a point is a diagonal, then we continue, otherwise we continue the loop. So if it is not a diagonal, you just put continue and it will continue. And if it is a diagonal point, we just search for the corresponding other 2 points using point 0 and diagonal 1, basically x coordinate of the point and the y coordinate of the diagonal point, and similarly x coordinate of diagonal point, y coordinate of the point. And if we have found those points, then we can calculate the maximum area the way we said, and then we can, if it is less than the current minimum area, you just assign it to the minimum area. And after getting out of the loop, if the min area is still equal to int underscore max, then we know that the minimum area has not been found. So basically there is no rectangle in the set of points that can be created that has the most minimum area. So we just put min area equals 0, and then we just print it out. Okay, I have 2 semicolons here. Anyways, so the solution works. Let me try coding it on LeetCode as well. I will mute myself now. You can also try it out if you want to. Okay, so my solution did work, and but the time complexity is really bad. So I will see if I can improve it, and I will also solve it in Python right now because, as I said previously, I'm also practicing in Python. So I will mute myself now and start practicing the question in Python. You can also do it if you want to, or you can skip this part. Well, I think the improved solutions are using hash map, but since we are practicing sets for now, I'm not going to be using hash map. I will just start with a set. So I will just start solving this problem in Python now. I'll mute myself. You can also try it out if you want to. Okay, so I finished this problem in both C++ and Python. Now I will just move on to the next question quickly. I will mute myself now. You can also try solving it with me if you want to.
Subsequence. 1. 2. 3. 4. 5. 6. 7. 8. 9. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. 23. 24. 25. 26. 27. 28. 29. 30. 31. 32. 33. 34. 35. 36. 37. 38. 39. 40. 41. 42. 43. 44. 45. 46. 47. 48. 49. 50. 51. 52. 53. 54. 55. 56. 57. 58. 59. 60. 61. 62. 63. 64. 65. 66. 67. 68. 69. 70. 71. 72. 73. 74. 75. 76. 77. 78. 79. 80. 81. 82. 83. 84. 85. 86. 87. 88. 89. 90. 91. 92. 93. 94. 95. 96. 97. 98. 99. 100. 101. 102. 103. 104. 105. 106. 107. 108. 109. 110. 111. 112. 113. 114. 115. 116. 117. 118
Okay, so I finally solved this question as well. This was such an unnecessarily long question that required a lot of debugging and stuff. Although for practicing something like sets, I don't think it was bad by any sense. It was pretty good. First of all, I would like to tell you where I was lacking. So first of all, I made a mistake in merging. So you can't change a value in place in a set. What you have to do is first you have to erase the previous value and then update it with the new value. So I was making a mistake there. I was trying to change the value in place. That did not work. Other thing where I was making a mistake is that it is with these conditions. I did not check them properly. So previously I was doing left less than equals to p dot first. That was wrong. That would not have worked because it was taking p dot first to left, but that would have made a mistake. And similarly with this one as well. So let me show you what was a condition previously. Yeah, so these were the conditions previously. I was doing left less than equals to p dot second, but that is wrong because since I am checking the overlap from right, left being less than equal to p dot second would not work. When we want to remove a range, we should check if the right exceeds or not. So that would work. So as I said, we should check if the right exceeds from the right or not. And in this, instead of checking it like this, we should check if left is less than p dot first or not, and that should work. Unless I have to place these two conditions above this one. Yeah, so this works. Then if we submit, all of this should work completely fine. Yeah, so this works, although this is definitely not even close to being the most efficient solution. It is a solution solving it in 28 milliseconds, so it is far better than mine. This is much better than mine. But anyways, I will explain the solution to you in a second. Okay, so now let me quickly explain the code to you. So what we are doing in the problem is first of all, we have to apply the merge set theory in this. So merge intervals, you might have done that problem before. So when we are adding ranges, what we can do is we can merge the intervals to make our life easier. So we have an interval, for example, a comma b, and we want to merge it with x comma y. Now we just have to check if they are overlapping. So if they are overlapping, then a is going to be less than equals to x and b is going to be greater than x, right? So this is the simplest overlapping condition.
That.
And if this condition is satisfied, you just do a comma y. That is exactly what I've done in my code as well. So if the first of this, which is a, let us say this is already in the set, this is already in the set, but this comes before in the set, then what we can do is, actually let me show it to you with a better example in this case. So we'll keep that one as well to make our lives easier. For example, you already have this and we want to add x comma y, right? Somewhere inside of this. So let me explain to you merge range with an easier example. So we have 2 comma 5 and we have 4 comma 10, right? So what do we check in this? Let us say we have this in a sorted set, right? So we will have to merge these two starting from the left. So what we can do is we can check if these two are overlapping. For that, what we can do is we can see if the second element of this first range is greater than equals to the first of this second range, right? Since it is, So we know it is overlapping, so we can combine these two and write them as 2, 10. Simple as that. That is the simplest explanation I can give of this. So then you can write a simple merge code. For example, you already have this array, but you can do, or this set. This is an ordered set. What you can do is you can add this to this ordered set, and after adding, you can start checking from the left and start merging the elements together in the set. So that is all you have to do. I'll explain in my code as well. Actually, let me show it to you in my code first. So in my code, first of all, let me change these two conditions quickly. Yeah, so this is the add range code. What I'm doing is I'm first of all adding this element to the previous set. So since this is a sorted set, it will place it in its place wherever it is, and then we are going to create another set. I will call this the merge set because we are merging the elements in this set. So what I'm going to do is I'm going to start adding the elements in this set. So if the merge set is empty, we just add the first element inside of it and then continue. And then if it is not empty, what we are going to do is we are going to take the last element of this merge set, and then we are going to check if this last element overlaps with the current element that we have in the set or not. If it is overlapping, then we update accordingly the current element, and then we add it to the merge set. That is all we are doing. And obviously, since we cannot add it in place, we obviously remove the first one from the merge set before adding the current one. And then at the end, we just set the current set to the merge set. So that is what is happening in add range. That is a way you can merge the intervals in the sets. And then we can move on to second condition, which is remove range. Now in remove range, we get many conditions. So we already have a set a comma b, and we get any range x comma y, right? Now there are multiple possibilities with this. The first one is that it completely overlaps with this a. The first one is that the range that we have to remove happens to be a sub range of this range a comma b. Then in that case, what we are going to be adding is a to x and then y to b, right? Because this part in between is going to be removed. So that is what we are going to do. And then the second case can be that it only overlaps with the first part. In that case, we only add this part as this first part is going to be removed. So, and then the third condition, if we are overlapping on the right side, this condition, then we are going to be removing this part and only leaving this part in, which is going to be this. And in the fourth condition, the current range that we have is going to be a sub-range of the remove range. If this is a sub-range of the remove range, that means we are going to be deleting this whole thing. That means we can just continue in that case, right? So that would work. And another case can be if the remove range that we have does not overlap with the current range at all. In that case, we are going to be continuing as well, meaning we won't remove. Or you can also say that we can just add this inside. So we'll keep a comma b in that case, right? So that is what is happening. Now, the condition where I was making a mistake was with condition number second and condition number third, where only the left and the right half can overlap. So what I was doing initially, I was checking if this second was greater than this right or not, but this left or not, or basically y can be greater. I was checking if y is greater than a or not, but we have multiple conditions for this. Now y can also be greater than a when there is a complete overlap. Y can also be greater than a in this case where there is only right overlap, right? So that would not have worked. So instead, what we have to check is if x is less than a or not. That way we can find out if it is a left overlap or not. Similarly for this, I was checking if x is less than b or not, but again that case would fail because this can be a complete overlap case as well, or no overlap at all. So to avoid these, what we just check if y is greater than b or not, and that way it worked completely fine. Now let me show you the code to explain it better. So in the code, in remove range, what we are going to do is we are going to be creating a remove set in which we are going to be adding the new elements or the new intervals. So we are going to be iterating the previous set that we have. Now we are going to first of all check if there is no overlap or not. There is a condition of no overlaps. If there is no overlap, then nothing is going to be removed, and then we are just going to add the current element. Otherwise, we are going to check if the current range is a sub-range of remove range or not. Let me write a sub-range of remove range or not. If it is a sub-range of remove range, that means that whole interval can be removed, as I have shown previously. In this condition, the fourth condition. So it can be completely removed. And the next condition is to check if the remove range is a sub-range of the current range or not. If it is a sub-range of the current range, basically it is this condition, the first one. If it is sub-range, then we add like this, right? So that is what is happening in this condition. We just place p dot first till left and right till p dot second. So basically left to right is being removed, right? And then we get to the last two cases where I was making the mistake. So now we just check if we have a right overlap or not, or a left overlap or not. If it is a right overlap, then we are just going to be adding whatever is left on the left side. We are going to be removing the right element, so we will be adding p dot first till left. Otherwise, if it is a left overlap, then in that case we are going to be adding right till p dot second, and then we will just set this remove set equals to the current set. So that is the way we can do this remove function. Now it took me a really long time to debug it because of this single condition where I was making the mistake. So this question became tough because there were too many conditions, but otherwise logic wise it is not that difficult. But okay, good question, I would say. Anyways, then this query range is really simple. You just iterate the set and you just check if you have an overlap or not. If there is an overlap, you just return true. Now there has to be a complete overlap. So basically the range that we get has to be a sub-range of any range that we currently have, because now the ranges are not overlapping. So the only way for a particular range to exist if it exists as its own interval or not, or inside its own interval or not. So you just have to check if it is a sub-range or not. If it is, you just return true, otherwise you just return false. Now this code worked completely fine in C++. I can also try solving this in Python, but I will be honest, I want to get done with this set of questions as quickly as possible now. I'm not going to be wasting any more time. I will just move on to the next question and finish these sets of questions finally. I don't want to take too long. So now we can just start solving the last question finally. You can also start solving it along with me if you want to. I will mute myself now. Okay guys, so I have solved this problem as well. This was a very simple problem. Not like last question worthy, but anyways, although I was making a mistake in this, I will explain in a second. First, I want to tell you that this question is available on LeetCode, but for that I have to buy a subscription. I don't have any money for that, so I'm just going to be submitting it on Geeks for Geeks for now. So let me explain the solution to you quickly. In this, we just have to find longest substring with exactly k distinct characters. Now that is really simple. Let me show you the problem here only. So we are given a string and an integer k, and we have to find length of the longest substring with exactly k distinct characters. So we can do a sliding window approach in this using left and right pointers, and since I am practicing sets instead of a map, I am just going to create a set which will be functioning as a map. Very inefficient obviously, but no choice. And then this variable longest sub, this is going to be storing the answer. Then we run a while loop until the size is less than right. I don't think I need this condition. Yeah, I don't think I would need this condition anymore. So let us also try and run it quickly just to make sure. It will take a second. Yeah. So yeah, the solution works completely fine. As I said, very simple problem. So in this, one mistake I was making is I was not checking if this iterator is found in this frequency map or not. Just kind of slipped my mind. I was thinking about something else, but anyways, so I corrected this. If it is not found, then we just insert obviously with a value of 1. Otherwise, we take that element, erase the previous one, insert the new one with updated value, and from the left we run a while loop until the number of elements are not less than equals to k. In this case it will be equals to k, but okay. Anyways, then if the frequency size is equals to k, then we just check if it is greater than the current maximum. If it is, then we just print the answer. Now let me quickly paste this in Geeks for Geeks as well. I'm not solving it right now. As I said, I want to get done with these sets of questions as quickly as possible now. So let me just quickly finish this up. String s, okay, we have s in this and we had k. Okay, this works. Yeah, this should work. Let us see, quickly compile and run. Off and solution, very simple. Hopefully it works. Okay, compilation completed. This is correct. Just submit quickly. Yeah, so extremely simple problem. Now it was kind of a waste of time, you can say. Could not submit it on LeetCode either because they are not allowing free users to solve this problem, and this is not even an exceptional problem, like such a simple problem, such a pointless one. So anyways, now I will be ending this video here, and this was really fun. We solved a lot of good problems in this, although some of them technically did not need set, and I could have just used a map or something to make my life much easier, but anyways, that doesn't matter. Now that I've completed this, I can finally move on to trees. So I will see you next time when I'm solving tree questions. So anyways, have a good day, keep practicing, and yeah, goodbye.
So please whatever. Please I want to reach 1 million likes. So please sarapakarai. Okay, thank you.